So odd, even, neither. We got to get that on the books because this is tricksy for some of us. Parent function, x squared, parabola. This means right 2, up 1. So I'm thinking, here's my parabola, right 2, up 1, parabola. So if I said, is that odd, even, or neither? That is a no-brainer, neither. It doesn't have, do you guys remember that even means y-axis symmetry? Y-axis symmetry. And odd, that's a different kind of symmetry. That's symmetry about the origin. Origin symmetry. Gigglies. But it gets really hard to tell sometimes. The symmetry is not always visible ocularly. That means through your eyes. You got to be more sophisticated. So the real trick is this. Negative x goes in. If you get the same thing out, it's even. If you put negative x in and you get the opposite out, it's odd. It's the algebraic test in case your eyes are not able to determine odd and even just looking at it. It happens. So if I were to graph this one's actually pretty easy to tell. It looks kind of odd, but let's do the test on it. I am going to put negative x into that function. So negative x is now cubed, and negative x gets multiplied by 6. And you always use parentheses. And then when you simplify, you'll see that a negative to an odd power is still negative. And if that becomes minus 6x, that, if you factor out the negative 1, is definitely the opposite of what I started with. That is an indication, since this is the exact, here's the original, there's the negative, this thing is odd, totally odd. Symmetry about the origin. So that's the algebraic test. Super duper, works every time. Describe these. What's that, Grace? I'm sorry. Okay, no problem. V flip. Tell me what they are. V stretch. I hope you guys have nailed this down, that when you guys have a outside the parent function thing, it's vertical and it's as is. Simple, simple. Keep them simple if you know they're simple. It's the inside, my parabola here, for instance, it's the opposite. Like, remember that's left 7. And this is down 3 because it's vertical. Inside, outside. Inside's horizontal, it's opposite. Outside is vertical, as is. Okay, by the way, this is the of that didn't show up well in this translation. That's okay. The notation is the right function goes in the left, in that g of f form. The right goes in the left. It's the same thing as g of f of x. The right goes inside the left. And it looks like this. G, you take out the x, and you leave room for whatever f of x is to go in its place. And this, again, I'm going to totally take advantage of Ethan's skill with transformations. This is my composite function, my Goff x. Remember, my Goff GTI is coming in the spring. It's going to happen. We're going to do it. Well, it's Golf GTI. But gets me excited just to even mention it. This, remember it says up top, please find the domain and the range. If I'm looking at my dirty dozen, that's a parabola, and that's left 3 and down 2. My domain is all reals because I know everything about parabolas. Range, though, since it's down 2 and it's facing up, that thing goes from 2 to infinity because I'm picturing in my head this left 3 down 2 parabola, and I'm thinking, oh, that's at negative 2 right there. And it touches. It's got a bracket. So that's how I determine my domain and range on those. If you go the other way around, f o g of x, g goes into f, and you got it. All right, so if I were to get Gabe's professional opinion, and I put g into f of x, then I'd get 3 plus x squared minus 2 there is yet another parabola. And that ends up being x squared plus 1. So my thought is, I'm just looking at the picture in my brain saying the domain, it's a parabola, it's all real. And then the range, Gabe, take it away. I got an up 1 parabola. What do you think the range is on that thing? I just moved it up. What's the lowest it gets? I'll tell you the highest is infinity. And this one is up 1.
Oh, it's up 1?
Yep. The other one was negative 2 because it was down 2. But this one's at positive 1, up 1. Yep. Yeah, previous one was negative 2. This one's positive 1. Different graph. I'm using your dirty dozen knowledge to help you find domain and range. You can graph these. That's the goal. Uno momento. We're going to finish we're going to do inverse, how to do a radical, and we are done with this thing. So I want you to find the domain and range of this little dude. If y'all can imagine with me, this is 1 over x that is right 2 because of the minus 2. And do you guys see the vertical stretch? V stretch by 3. So this graph, I know and love this one. This is move it right 2, vertical asymptote, make a really stretchy 1 over x graph, call it good. That is the sketchiest sketch I've drawn in a long time, but it's good enough. Because I just need some basics on what's the domain and range. And that's how I do my domain and range. I go, hey, domain looks like it goes from negative infinity to that 2. And that's exactly what I write, negative infinity to 2. And then 2 to infinity. The range looks like it breaks. Oh, it has a break in there. And you want to always double check what your horizontal asymptote is just to be sure. And my aha in this case is y equals 0 because it's bottom heavy. So I'm not guessing. I'm totally using my skills with rational functions to know, oh, that's y equals 0. So the range is negative infinity to 0 and on 0 to infinity. The inverse, I need to tell you a brief story about. Y'all remember f of x, we just make it into y. We swap x and y. And we solve for y. That's it. And that's how you get the inverse. The cool story is the inverse domain and range is the swap of the domain and range of the regular function. So all we're gonna end up doing when we get the inverse, you're gonna notice that the domain and range are gonna swap. These guys are just gonna take the place of each other. What was the domain of one now is the range of the other. Because if you think about it, you swap everything x and y, so you swap the domain and range, which are x and y components. Coolio. So that part's easy, but I do need to actually figure this out. Y equals 3 over x minus 2 is step 1. Swap x and y, so now x equals 3 over y minus 2. I do not like fractions, so I multiply by the denominator. Now, some of you remember I said you could swap those guys and put the x on the bottom and the y minus 2 on the right. That's actually good too. I would like to do that as well. But that's the idea, is canceling that out. And ultimately, I want to get y by itself. So you might y minus 2, x equals 3. And then you divide both sides by x. Do you see that if I would have just swapped the whole number, or the number that the fraction's equal to in the denominator, I would have gone to this step right away. Such a great trick. I love that. Swap the x and the y minus 2. It's a good trick. Add 2 to both sides and you're done. Y equals 3 over x plus 2. Now I know that sounds goofy, but if you take a look at it, Ben Parks, look at this. This is still a 1 over x graph that is vertically stretched by 3, and it's up 2. So if I think of that, it's a little bit different. Remember, the other one was vertically stretched by 3, but it was right 2. This one's up 2. So It does end up looking, it kind of swaps the motions too. The inverse moved in the kind of the inverse way. Your domain and range you shouldn't even think twice about. So when I say what's the domain and range of the inverse, all we're going to do is we're literally going to swap them from what they were in our original function. So if you guys see the range in my original is going to be your domain. And then your domain of the original, which I'll do in a different color, that little number right, that dealio is going to be your range. If you graph it, you'll see that's totally true. They just swap, and I love that. I love that when you invert something, the ranges just swap, because that's what inversion is, swap x and y. Everything x and y describes gets swapped. Almost there. I got to solve for x in number 6, even though there's hardly any room left in there, but I can do it. You ready? This is your job. Isolate the radical, then square both sides, because everybody forgets that part. It's just like logs and exponents. You have to isolate that stuff before you do the inverse. Isolate what you want to do the inverse to. Isolate the radical. Then square. And then I'll let you finish the rest on your own. Don't forget to FOIL out things. So the foliage or distribution, please. Quadratic formula, set equal to 0 if you have to. All that stuff comes into play, just fair warning. And finally, number 7, you guys are going to do stats, edit, plot on, plot one on, zoom, stat, and then you're going to find a graph that fits it and do some cool, answer some questions about it. So that's it. That's the, you guys can handle that. We can talk about it more on Monday, and you can look at the key and stuff. But I wanted to get you prepared for that. Done for now. Cool. Do 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 do.